All right, so let's get started. And next around 40 minutes, I'd like to give you an introduction about Kotlin. So, short introduction about myself. My name is Christian. I've been working as a Java engineer for the last 12 years. Since 7 years, I'm also working like more in the full stack way with Angular, TypeScript, JavaScript, and of course also with Kotlin. So, if you have any questions during the talk, you can just go to type.rocks/QA, or you can scan the QR code. You can then enter your question in there, and we will see, we go to the questions at the end. Of course, you can also just ask them at the end, but sometimes it's easier if you type it so that everybody can also read it at the end of the talk. So, short introduction about what really is Kotlin. Kotlin is first a multi-paradigm language. So what this means is you can program in object-oriented ways, but also in functional ways. And it's developed by JetBrains, and also from the open source community, so you can go to GitHub, you can also contribute there. And it's inspired by many other languages. So Kotlin is really like the JetBrains guys and girls that really have taken everything from other languages which they felt that the developers need and put them into one new language. So for example, they've taken Java, Scala, Groovy, and many other languages and like created this new language which for them is like the perfect one for developers to develop on. And last but not least, it's also multi-platform. So you can, of course, compile to the JVM, to JavaScript, Android, iOS, but even native, and you can also like share your code between different platforms. So, but there are many great languages, but how many of them are really used in production? Kotlin is really used, for example, in Google. It's the main programming language for Android. So if you're developing an Android application, Google itself tells you use Kotlin over Java. For a long time period, Java was used as the main programming language. Now they switched it. Of course, it's also used by Amazon, like companies like Slack, Pinterest, and I'm from Switzerland, so I've been working in many like insurance companies and also in banks, and almost all of them use Kotlin in their backend for their Spring Boot applications, but also alongside of Java. So they don't like have just Kotlin or just Java, but they have like a mix of it, and this really works great. So for example, one insurance company has like their whole customer portal backend written in with Spring Boot and Kotlin, and they of course also use Java interchangeably. So, but why should you care basically? First is you have first-class Spring support. So if you go like to the Spring.io website and you want to create a new project, then you can just click and say I want to use Kotlin as a programming language. So it's not like this niche, but they really try to push Kotlin even in the Spring environment, and they have like features which are only available in Kotlin. So of course, you also have excellent build support for Maven and Gradle. If you have like an existing Java project, Gradle project, you just add in the plugin and you then can compile Kotlin alongside of Java. You don't have to like say, I want to use only Java or only Kotlin. Next thing is also right about interoperability. You can easily call Java code from Kotlin, Kotlin from Java, no problem. We'll see this in the live coding. And you have full access to all the Java libraries there are. So if you everything which is on Maven Central, basically, you can use in Kotlin, because you can just call Java code from Kotlin, also like Apache Commons, all the libraries there are, you can just use them. And last but not least, it's also stable and used in many places. So it's not like this one language which is used like in one company, but it's used in a variety of ways. Yeah, and let's already start with the live coding. We will see these 8 topics, and we will start easy with type inference, some string magic, and then at the end I will show you how you can use Kotlin in Java and vice versa. Yeah, so let's start the code. I'm here in IntelliJ, so there are 2 files. At the top you have like a normal Java file. This I will need to show you the difference between how we do it in Java, how we do it in Kotlin. At the bottom we have a Kotlin script file. There are 2 different file types. There are KT files, which is the equivalent to a Java file, and there is also this Kotlin script file. The only difference there is Kotlin script gets compiled in memory. So this helps us doing things like this. We can then say, for example, hello build stuff. And because it gets compiled in memory, IntelliJ has something called a worksheet, a Kotlin worksheet, and this allows to print out what's in the code right away. So it's really cool for prototyping, but also, of course, to show off some of the features. So let's get started with the types and type inference. So let's say we have a variable here. We use the var keyword to create it, and we then say, for example, build stuff. Now, what we can do, because Kotlin knows type inference, we can say, well, I don't need this explicit string. And Kotlin is still statically typed because it's like a JVM language, it's compiled to JVM bytecode. But Kotlin still knows that this is a string. So if I try to assign this to a number, this will not work. But Kotlin wants us to use immutable types whenever possible, so immutable variables. So Kotlin provides val, and this way it's like a final in Java, and now you can't even assign it to another string anymore, like you would use final string, for example, in Java. Now, but what you also can do is, let's say you want to concatenate the string here. And we say we have our plus in Java. Of course, in Java you could use string format, or with these new string syntax, you could also have like pattern templates. But Kotlin uses something different. Kotlin tells you, well, you can use the $sign and then your variable name and use it right away in your string. You don't have to like concatenate it. What you also can do is you can also say, for example, you have your curly braces here with the name and then the length. And then you can use even complex stuff inside your strings without having to like concatenate it or create a variable first and then use it. So of course, you can also use the multi-line strings like it's in Java. It's basically the same there. So Kotlin really wants us to use expressions and immutable code whenever possible. So, but how does Kotlin support us doing this? Let's say we have like an if-else block, and we have like name, in this case is build stuff, and in the else case it's just, let's say, something else. Now, the problem here is that we have to make our variable mutable, because otherwise we can't just reassign our variable. And this works perfectly fine here. But the problem is, now it's a mutable variable. Now, Kotlin wants to support us in writing immutable code, and this is why they said that the if statement is not a statement, but also an expression. So what you can do is, you can just put this and use this like a ternary expression. So we can then say we don't want to have this explicit assignment. And now we can change this and say this is a val, because the last line in this if-else will then get assigned to the string, to the variable. Now, of course, they don't stop there. You can also say you have a try-catch block like this. And we say here we have our exception. And here we even see that we could even use the Java lang exception. So you have access to all the Java classes also in Kotlin. But let's use the Kotlin one. Now, as you can see, this is still exactly the same. But if we throw an exception here, and as you can see, we don't have to use the new keyword. We can just call this like a normal function. But of course, it calls the constructor. We can then just say, we want to throw an exception, and then we will get the value from our catch clause, and something else now is in our variable. So this way, you don't have to like create a variable up here and then in the try case assign the value, but you can like assign the result of this try catch immediately. So there, of course, are also like pattern matchings, like with the switch expression, like in the recent Java versions. This works basically the same. That's why I will not show you the details right away. But what I'd like to show you is how you can work with functions. So let's say we have an easy function here. We have a function hello, which takes a string as a variable, and it returns a string like this. Now we say return and hello, and have here our name. Now, of course, we can save the result here in a variable and call our function like you would do in Java. Now, there are some differences in these functions. First one is you can't reassign the value of your parameters. They are final by default. You cannot change this. The second one is if you have a function which immediately returns. So if you don't have any code, but you immediately return a function, for example, if you have like, you pass in a list and then you filter it and then you collect and return the value. What you then can do is, we can remove this return here and these curly braces and add an equal and have a so-called expression body. This is like the same as we have seen prior, but with much less boilerplate code. So what we also can do is, let's return here. What's also funny is that if we don't want, let's say this hello function should not return anything. So we basically make a void function. We just say here print line, and we call it like this. And now we remove this string return. As you can see, we still don't get an error, and we can still assign the result, the hello result, to our result variable. Why? Because even if you don't say you have a return type in Kotlin, it still has unit as its return type. Unit is also like an object. And the cool thing about this is you don't have to handle a void function differently than a function which returns something. Because often, for example, also in testing, you have to handle void functions differently than the ones which have a return. And with this approach, you don't have to have like these different approaches of handling functions. So this is like a simple way of using functions, but let's say more a real life example. We have a create box here. We have a width and we have a height in here. And we say we have a box here, and the width of this is our width, and the height is our height here. Now, of course, we call it like this, say 150 and 100. Now this works fine, but let's say we go back into our code later and say, oh well, I have to add like the coordinates to it. Now let's say I go in there, I say, okay, x here is my x and y coordinate, and I say I have here my x and y. Now I go into my code and I say, okay, yeah, well, now I have to add default values because, for example, for my implementation, I don't really need these coordinates. So I add 0 and 0 here. And now what you can see here is, of course, that they are in the wrong order. And you maybe think, yeah, well, I'm here in IntelliJ, I can exactly see that this x here, the order of the parameters is different. But let's say you are in a pull request and this looks like this. You have like just 4 properties, and let's say you also have like flags in it, or like a function with 10 arguments, and you have like flags and strings and something in it, and you don't really know for which property, which element, what this means. And this is exactly where Kotlin helps us with default and named arguments. So what we can say is, well, this 150 I want to assign to the width, this 100 I want to assign to the height, x is 0, and y is also 0. These are also called named arguments, and this way we are not anymore, we don't have to use it in the right order, but we can just assign it to the value we'd like. And Kotlin does not stop there, we can also use default arguments. So we can say, well, if x here is not set, just use 0. If y is not set, use 0 as well. Now we can remove all this stuff. And as you can see, this still works. And what we also can do is, if we want to say, well, if the height is not specified, we will just use the width. So we can say, if in the case where it's not set, we just use the width as the height. And now if we remove this, we can see that we get the width and the height of 150, and without having to create overloaded functions. In Java, we would now have created like 4 functions because we have one with x and y, which is not set. We would have one with only the width set. So we would then have all these overloaded functions, and it's basically the same code as this one line. So also what I really like about this is it's like a builder function, because you can clearly see which elements are required and which ones have default values, and you don't have to provide them. Because if I don't provide this width here, you can see I will get an error, because it tells that the width has to be assigned. Otherwise, it will not work. So this is like some intro to functions. Now let me show you how we can work with classes. So, for example, in recent Java versions, we have the records, which we can use to create simple classes easily. The same we can, of course, do with Kotlin. These are then just called normal classes. Let's say we create an address. We say we have here a street, and this is a string. Now, let's say we have an address here. We want to create an object, and let's call this build stuff street1. And now, the cool part about this is you don't have to create like getters and setters, because Kotlin does this for you. If you access address.street, then we can see we get the value, but it will not access the property itself, but the underlying getters and setters. So Kotlin here generates a getter for you, which then gets returned, which then returns the value. But if I here try to assign a new value, this will not work, because I've said this is a final variable. I had to change this to var, and then there would be the underlying setter would be called, and the variable would be updated. Now, what you of course also can do is you can create a more complex class. You can say you have your secondary constructor with other values in there. You can also say you have a static object, where you can say this is a so-called companion object. Everything you write in there is then right on the class. So for example, if I have like I'm static, and we have here a string, I can then access the address.I'm static like this. But you don't really often need this because Kotlin has top-level functions, and we don't have to use this companion object that often. So, but let's say you have two addresses here, address 1 and address 2. Now, we want to compare these two, like this. Now, we can see here, of course, this returns false. But with double equals in Kotlin, this does not use the reference to compare, but it uses the dot equals. If you use triple equals here, then of course it uses the reference comparison, but with double equals, it uses the object dot equals, and so you don't have to care about like if one is null or the other one and you get a null pointer, but this will be taken care of. But of course this is false because we have not overwritten the equals in hash code. So there is like, it just checks for referential, if both references are the same. But what we can use is, we can say we want to have a data class. What are data classes? We can see that now as returns true, because data classes override the equals hash code and toString. And this way, we also get, if we print out this address here, we get a really nice toString, where we also see what the properties are there, and what we would not get if we would not have the data class. Then we would just have like a reference toString. So this is how you can easily work with classes. Now, let me show you a little bit more about, we will go back to class a little bit later, but let me show you a little bit about null safety. So how do you work with null safety in Java? Well, let's say we have here, we have a function. Let's say we want to have like a function which returns a string, and we have here a hello, and we have a name in there. Now, what we first have to do is we have to check, well, if the name is null, in this case, we return null. Otherwise, we return hello and the name. Now, the problem here, of course, is everywhere we use this function, we have to check for null. Now, what can we do with Java 8 or newer? We can say we have an optional here. Now we have an error. We can say we want to wrap this in an optional. Now, the problem here still remains that we don't get an error anymore, but we just return null here in this case, because optional also is just like an object which can be null. So, of course, you should trust that this is not null, but it's always an optional. But just to show you that Java does not really have this null safety implemented. They try their best to fix this, but it's just not possible to be really null safe in this case. So let's see how we can do this in Kotlin. So let's say we have a function here, exactly the same as before, and we return here a string. We now say again, name is null, then in this case return null, otherwise we just say return hello and name. Now we get an error and a warning as well. The first one is condition name equals null is always false. Second one is an error, and we can see here that null cannot be a value of a non-null type. So why is this? Well, let's try to call this with null. We can see this gives a compile time error. Why? Because we've been working in Java for so long that we think, well, this string can always be null. Everything we pass in could always be null. But it shouldn't really be null, because we clearly say this is a string and we return a string. So everybody who calls this function should trust us that it's not null. So how can we change this and tell Kotlin this might be null we put in or return? We can just use a question mark here. And what this does is, if you check the JVM bytecode for this, you see that this creates the exact same class, exact same function like in Java. But what it does is it creates a comment above the function, which then is parsed by the Kotlin compiler, that the Kotlin compiler sees, okay, this takes in a nullable string and returns a nullable string. But there is not like another class created which is like called nullable string or something like this. It's just like in the JVM bytecode there is this comment which the Kotlin compiler reads. So this is like a simple way of having null safety. But let's say also we have a person here, and this person has an address. So let's have this address again, and we have the street string here, and we say this person has an address. Now, let's say you want to access the street of this. Now we can say get street, we pass in a person like this, and return a string. Now in Java, what you would do is you would say, well, if person not equals null and person.address not equals null, in this case, we return the person.address.street, otherwise we return null. Now, of course, what we again have to do is we have to say we could return a nullable string because it could be that one of these are null. But now we have also to say, okay, person could be null, and the address here also could be null. And now we have basically valid code, but Kotlin wants us to write more simple code. And so Kotlin tells us we should not use null checks, but replace it with safe calls. What are safe calls? What we can say is, for the ones of you who maybe have worked with JavaScript or TypeScript, you can say, well, if the person exists, with this question mark, we then check if the address exists, and we then say, well, in this case, return the street. Now we can remove all this stuff here, all this if block, and even change this to an expression body, and we have basically the same code which you would write in Java, but like in one line and really expressive, because here you can't make an error to forget to add to check for one depth. For example, let's say you have an object which has a depth of like 5, and then you forget one null check, and then sometimes you get a null pointer exception. There it's not possible because you know exactly if you which of them are nullable and which not, and you have to check it, otherwise Kotlin will show a compile time error. So I think this is really nice to work with, especially because you don't have to handle all these null pointers anymore. So now let's look a little bit about more of in the functional programming way. So let's say we have here a normal function is string length 5, and we pass it in our string, and we say string.length equals 5. Now, how would we do this and convert this in a lambda? Well, how would you do this in Java? Let's see how would we do this. The first thing we would have to do is we would have to think about, well, what is the type of the function we want? Want we a function or a predicate or a supplier, consumer, a runnable, or a buy function, all this stuff. So we would think, okay, we can use here either a function or a predicate. Let's say we want to use a function here, and we say as an input we have a string, and as an output we have a boolean. Now we say is string length 5. And we now can say we have our string which we put in, and we say string.length equals 5, like this. Now, but how do we call it? Well, because this is a function, we would say, okay, we call it with isStringLength 5 and pass in our string. But of course, this is not possible because for Java, it's just a wrapper over an object. So what we then have to do is we say apply. But this is not really functional in my opinion because it's so much code but I only want to have like to write a normal function, but as a lambda. So also, like if I want to have like 3 inputs or something else, I would have to create my own functional interface to be able to really have such a function, such a lambda. Well, how is this working in Kotlin? In Kotlin, let's see how we can convert this. So what we can do is, the first thing we say is this is no longer a function, but it's just a normal variable. And now what we can say, okay, the type of this variable is it takes in a string and it returns a boolean. And this is basically all we have to do to say which type of lambda it is. You could also say you have like another string and an integer and a boolean, and you don't have to create like something special for it. Kotlin does this for you. So, but let's keep it easy with the string and boolean. Now, let us create the lambda for this. We just add curly braces, and we put it inside here, and we say, okay, string like this. And the cool part about this is I can call this like I would a normal function. So you don't have to like call apply on it, but it's like just like an alias for a normal function, but it's a lambda in this case. So now let's use this lambda and loop over a list or filter a list. Let's say we have our list here. How do you create a list? You say list of, like this. And you then can, for example, say hello and world and let's say here build stuff. Now, the important part here is also, again, with the immutable stuff. If you say list.add, this will not work because in Kotlin, per default, all collections are immutable. So what you would have to do is you would have to say this is a mutable list. So of course you can make mutable list of everything, of all collections, but per default they are immutable. So, but let's now say we want to filter it. We have our result here, and we say list dot, and now in Java you would say stream. And we see we can still use a stream, and we can still use like parallel stream, everything. But they have analyzed many open source projects, and often what we just do is we have a list, stream, filter, collect, or list, stream, map, collect, and we don't really need this lazy evaluation which the stream brings us, so we just have boilerplate code which we basically don't need. So we have also the possibility to use filter right away. So, but there is not only filter. As you can see, there are so many implementations on the list which we can use to make our life much easier. So for example, we have also this filter not, filter indexed. We have also like, if you check the map, we have map indexed, map not null. We have like partition, we have zip, we have group by. Everything we would have to like go to Stack Overflow to find something special, then copy it. Here it is in Kotlin, right, baked in. But let's keep it easy and say you want to have a filter. This filter takes a lambda, like normal in Java, it also takes a lambda. So what we now say, we have this element here, and we say just element, we say this is string length 5, and we put in the element. Now, what we can do if we have a lambda in a function is if the last element in a function, last parameter, is a lambda, we can write it outside of the parentheses. So we can move the parentheses at front here. And because now it's empty, we can remove them at all. Now, lambdas are also special if they only take one input parameter. If a lambda only has one input, we can remove this explicit assignment and can use it instead, because this is like the implicit value which gets passed into the lambda. But I often really like to keep it like this, because this way you can add some meaningful variables to keep it more readable for the next developer. But of course, here we already have a lambda. So we can just say, we can remove everything here and say is string length 5. And then here we have our result, and we can see we have our hello world. But of course, we can also say we want to have filter not, because we want everything beside this, and now we get build stuff. So this are like these convenience features which I really like, that I don't have to code them each time I use it. So this now is really nice, and of course, by using these top-level functions, you don't have to like create like a wrapper class, like a string utils class, where you put in all your static functions. But there is even one other way to do this, which I really like much more, is, let's say, would it be nice if you would have like a string here, and we could just call is string length 5 on this string, that we don't have to like pass the string every time in our function, and we can clearly see which functions are available. We can do this by using extension functions. So what are extension functions? So the first thing we do here is we have this normal function. What we now say is, okay, but on which type do we want to call this function? What we then say is, we want to call it on string. And now we say, okay, string, dot, and now we can see it almost compiles. The only thing we have to remove is this parameter, because we don't need it anymore, because we are calling it no longer on the parameter, but on this. Now this looks a little bit strange if you see it the first time, because you maybe think, well, but how does this work? Does the string class get manipulated or something like this? Not at all. This is like syntactic sugar, and if you check the JVM bytecode, you can see that it creates a static, a string length 5 function, which then just takes the this as the first argument, and what it basically does is it just creates, it then accesses this and checks the length and does something like this. So it's like a wrapper for a static function, but it makes it much easier for us developers to write the code, because we can clearly see which functions are available on our object. Now, the cool part about this is also that you can use null as an input. Why? Because let me show you. Let's say we have a name here, and this is a nullable name, and it's null here. But of course, it's a string, but the string is nullable. Now, to say name.is string length 5, we can now see, okay, this does not work because it only takes a non-nullable string. But what you can say is, we just change this and add a question mark here to tell Kotlin we also want to allow a null type to be passed in. Now in this here, we also use a question mark to short circuit in the case where the this is null. And we can see here the code compiles. So this is also why it has to be like this, because you cannot call it on null, but you just pass in here this null string, and it will then just short circuit and return. And by using this, you, for example, also have other stuff on the string. You have, for example, is null or blank. And you can also call this on null objects, of course, because you can pass in this nullable string. So before we go to the last part, to the interoperability, let me show you how you can do this with your own classes. Let's say you have like a person class from a library or something like this, and you have a first name, which is a string. Now, you want to extend this class. Let's, for example, say here Superman, and we say we have a person. Now, the problem here is, if we want to extend it, we see this type is final, because per default, all classes in Kotlin are final. You can, of course, make them open, and then you can extend them, but Kotlin wants us to use extension functions whenever possible. They don't want to use us to use like this extends functionality. So, but how can we now use this? We can just say, well, we have the person, and let's say we have a function. Let's call this function greets. And let's even say we have another property we pass in. Let's say the person. We want to pass in a person. And we then can say this dot first name greets, and we say person dot first name. And now we can say we create a new person one here, and we have a person. And we now can say we have another one, and we'll say, for example, here Julia, and we can say person1 dot greets person2. And again, this is like creates a static function again, which adds the first parameter takes this, like the first one, and as a second parameter takes this input. Now, we can go even one step further. We can say if a function, like an extension function, takes a type in and is also used on another one, we can use a so-called infix function. Now, what this means, we've seen nothing really changed. But we can say, now we can remove this dot here, we can remove these parentheses, and this is still valid code because it's an infix function. And maybe if you have used Gradle or and you have used it like with the KTS, with the Kotlin script type of your build pipeline, then you have maybe seen such patterns, and so you can really create fluent code basically. Like you can write like text. You can write like, for example, if you have like your own DSL, you can use it like this. So. But before we go to the interoperability, there's one more thing I'd like to show you. Let's say you have to work with big decimals. Oh. Okay, froze. Yep. Let's go back. Okay. If you have to work with big decimals, let's say you have a big decimal 1 here, and you have a big decimal 2, and you want to have the result here. And BD plus BD2. And we now can see that the result, of course, is, well, let's see this, is 2. But this normally does not work, because in Java, you have to use the .add to count them together. So why is this? Because let's check what this plus here really does. This plus here, if we check here, we can see that this is a so-called operator function. And with these operator functions, you can use plus, minus, times, like all these operators, and can implement them for your own class. What you can also do, for example, is you can say you have a person, and you say if you have person plus another person, you can say it creates a group object, for example. And you don't have to implement like your own implementation for it, but you can just use plus, minus, and so on. And so maybe some people say, yeah, well, but I could override plus with minus, and of course you can do that, but that's like your problem. You have to really have to think about this if you do this, and it should never go into like live code. So, but before we end it, I'd like to give you the introduction to the interoperability, which I think is the most important thing to show, because this is where it divides, because if it's easy or not to use it. So I have to exit here my presentation mode, And what I now can show you is I have here a normal Kotlin file, a simple Kotlin file, and here's my simple Java file. And in my POM XML, you can see here that I have a simple dependency of commons IO. And this is just a normal project with just the Kotlin and the normal Maven compiler plugin, but also with the Kotlin compiler plugin. And now what I can do is, and I will go back for this into the presentation mode, what you can do here is we can just use Java code in Kotlin. So we have our main function here, and let's say we want to have our simple Java here, and we say simple Java, and we can just initiate it. Like, this is the same project, we can just call our Java code from Kotlin. We can also say we have our IO utils, which we import from Apache Commons IO. And this is not like a special kind of setup. You have just your normal Maven project, you then add the dependency, you say you want to also compile Kotlin sources, and that's it. And we can use everything here also from the IO utils. So you can use every library you'd like from Java also in Kotlin. And vice versa the same. Let's say I have a top-level function. And we say here it's a simple one, it doesn't really do much. Now, how can I access top-level functions in Java? Because Java does not know top-level function. It only knows like these wrappers, and then it calls like the static function. Kotlin knows this, and so what it does is it creates a wrapper class. It creates a simple kotlin.kt file class, and you can say I can access a top-level function by using this. So I even can use top-level functions from Kotlin in Java easily. Of course, I also can extend my simple Java here. I can just say simple Java, and I can extend it from Kotlin, and I can even extend the class, the Java class, and use it then in my Kotlin file. So this is really, I think, the main difference between many other JVM languages. Like the interoperability is just almost seamless. Like there are some parts, for example, if you work with coroutines, but this is like a whole other topic. It could be that you have to check some things, but for the normal stuff, like your normal daily application, you can just drop in some Kotlin code for stuff where maybe it's easier to work with Kotlin than with Java. All right, so let's go to the questions. Are there any questions? All right. I don't see everyone. Yeah, back there. It's really funny. Many people ask this. So the question was if there is any reason not to start with Kotlin. Maybe it's I went to many companies, and also we started then to use Kotlin there, and what I saw is the developers especially really like it. So it's like the learning curve is really nice because you can start with some small part, and then you can just change the files and so on, and you can even say you want to convert a Java file into a Kotlin file, and then it converts the code. So of course what I would not do is like if you have one guy who knows Kotlin and then immediately rewrite everything, because you always need to have like the support from your team. Otherwise, it's just especially for stuff that is like many people work on. But I really like using Kotlin, and I would really think that you should try it like in one project, and don't like start a new one with it, but just start on a small scale, and because for some parts, Kotlin is so much easier to work with than Java in certain parts. So I don't really see a disadvantage of using it. But of course, if there are many people who only like Java, then I would not do it, because then it's not worth the headache. Yeah. Cool. Then let's see if there are some questions online. It does not look like this, but it's totally fine because we don't have that much time either way. Yeah, I think this was already it. Thank you so much for attending. If you want to get in contact, just visit me on LinkedIn or on Twitter or on my website. If there are any more questions, just come to me back later or write me on LinkedIn. I will be glad to hear from you guys. Thank you.